Million to power millennium. Good morning to everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, March 22, 2022. March 22, 2022, Tuesday, and this is 3:21 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ. आज दिनांक मार्च 22, 2022 मंगलवार सुबह के 3:21. Talk continues in episode of quality and coordination, engineering projects, works, reliable engineers, communication, concrete, civil engineering, works contracts, safety, health, environment designs, construction methods, claims, organization, etc., etc. These are all these important issues, and you can see my email ID if you wish. As usual, you can note down if you wish SURAJ Suraj underscore, don't forget underscore, ENGINER engineer at yahoo.co.uk. And my title is Chartered Engineer India and International Professional Engineer India. That's for 5 years, and Chartered Engineer to an extent corporate membership of Institution of Engineers relates. And of course, this is another certification of international certification. International Professional Engineer, validity is 5 years and 30th September 2025. This is third certification in capacity as International Professional Engineer certificate. First certificate I obtained in 2012, and before that I was Professional Engineer and Chartered Engineer. This is Chartered Engineer India, and that is written here, you can say, by virtue of qualification of professional training and corporate membership, and Chartered Engineer India, and that is here, you can say, Hamlet Civil Engineering Division of Institution of Engineers India, and Fellow of Institution of Engineers India, membership certificate Institution of Engineers India, and this is Fellow, and of course this is quality file, which is important to be discussed every day, and coordination file, and first of all I close the file and Chartered Engineer file and open concrete file, which is from Japan Society. I downloaded from this is a concrete file. We're going to open. This is just now, it's a couple of seconds. And let's say here, it's called specifications, concrete specifications, Japan. That is standard specification for concrete materials and construction. And here it is. I go to page 70, I think 70 or whatever number it is. I'll see filling capability. We have seen this. Strength, that is durability of concrete materials, and steel production performance. We have gone through this water tightness, and of course as constituent materials, and we have to study. We'll see how to connect again. Like I exactly remember, we did not study that, so we go back to this page. That is chapter it is constituent materials, and before that we have just refresh what we did yesterday. Cracking resistance we have talked of course we'll do it again. We have water tightness and all this I remember. Steel production performance and durability of concrete. We'll start from here later on, and let's keep it here. And now I go back to quality file. Quality every day is a question mark, and I don't know why I don't feel bored. In fact, see, I don't know myself. I don't feel bored. I keep on talking and talking and talking. I don't know reason behind that, but my internal person says you have to speak about this because topic is like that. Topic is quality and coordination, and I explain, and you must realize this fact that quality is important for everybody. And in fact, for an engineer, quality is your religion. It's like that. Work and quality, whatever work as an engineer you should do, I should do, means it should be like religious practice. Means it's not religion physically, but engineering itself a religion. It's a religion because engineering uses natural materials. I consider engineering just like a doctor considers medical, how to treat patient. It's a kind of a devotion towards patient. That's what medical science says. You have to think of a patient. Even you are not taking food, means first priority should be patient. And same way I can say an engineer should, my first priority should be work should be done quality oriented, even if it's a temporary work or it's a preparatory work or it's permanent work, because ultimately it's going to stay for longer than life of person who spends money for that work. That person also doesn't know how long that person shall live, but that person knows this work shall live for many decades to come. That's difference in approach of understanding. My approach is that, like you think of your kid, you think of a child. My child at least should stay for as long as possible. My child should enjoy good life, one should have comfortable life, should rise in life. Every parent think that way. That same thing. Quality is a kid, it's a woman. I mean to say, it's a child of. Of course, you can say it's a woman who attracts everybody. It should be like that. Quality should be considered a beauty, and you should attract society. You go towards it so that it would come to you. Quality is like that. It's not. You can say you have to change yourself for changing quality. You can't combat quality and suppress it. Quality is that kind of mechanism because it's your own design. It's your own selection. It's your own scope. How much you want to accept, how much you want to use it. Of course, it relates to expenses. It relates to what sort of material you require for that work. It relates to everything like that. Means what material you need, what's the quality of that material, what's the quality of person who would do on that, what's the standard of people, the quality of persons, workers, personnel, what sort of machines you want to buy for that, means, and how much, what percentage of workmanship or workpersonship, or you can say trade standards you want to adopt. Quality means has got many vistas to be defined. And of course, coordination moves along with this, because coordination is media. Coordination is a kind of media that provides you with information, if not automatically through your own efforts. That's why it's called coordination, means it moves with you. If coordination does not move, you cannot move. And it's your own efforts. I mean, there's nothing physical you can say about coordination or quality, because product has inbuilt quality. We cannot say this is quality and this is product, both are combined, and we also cannot say this is coordination, it's also combined or merged in. But it's like, I breathe, I can't see my breath, I can't see my respiration, I can't see my soul, but my soul works and my breathing works and my body works. I can say I'm alive, I'm not dead. I can't say I'm dead, but I'm just telling you, somebody else would say I'm dead. It's kind of that. Means if you don't get quality, you don't care about that, your work is like a dead body. You think that your work should be dead body? Quality less work equals dead body. I can say only that. If you want to use dead body, it's up to you. Means if you want to dissect, just like medical science does, dissect it and know what are sections and what parts are there, how these parts relate. If you want to know that, you can dissect it, you can use that body. But otherwise, for surviving purpose, for service purpose, for use purpose, dead body doesn't value. So here is quality, that is living being. I can say, if you push quality, if you insert quality into work, it is like living being. Means otherwise, it's like dead body. You want to buy dead body or you want to buy living being, you have to decide. Nobody can decide for you. Quality and coordination, and we say engineering projects works. And engineering projects, so you can say, I'm talking of all engineering projects, not one or not two or not civil or electrical, because no project is independent in fact. You can take whatever project in life, we can say building, road, or you can say street light, may also powerhouse, canal, or these headworks, there are headworks at canal, and also you may say airport, or refineries, whatever you consider, nothing is individually based. either one. There is no single engineering that says, no, we are responsible for this. It's not like that. Many engineering branches are involved on every project. Generally, for example, in buildings, every engineering branch is involved. In power stations, generally more than branches are involved that are more than in buildings branches are involved. Same way for airports, for powerhouses, for fire, you can say it's combination of various branches. The projects are considered, and that's called project. Massive construction works based on massive designs and massive procurement of materials, and millions of workers to be involved. We get delivery of a project for many decades to come. These projects work. It's involvement of a large number of resources and natural materials. In fact, that is more important. When I talk of engineering, people forget. I forget also that nature has exclusive involvement on projects. We should not forget this point. That's why I say quality is important, because nature itself is a quality one. We can't change nature, we don't have that potential. We have no power even to touch nature. Human is not so strong. Still today, science is not that strong, engineering is not that strong, and no one is that strong. We can change nature, we can't change. Nature has its own system. It works accordingly. If it wants to build up, it builds up. If it wants to destroy, it can destroy within minutes. We have to think that way, and that's why we have to learn from nature also. Think of again and again, many times I explain that engineering can be learned from nature, at least gross engineering, or you can say abstract engineering, if not detailed engineering. We can learn a lot from nature as an engineer, as a student, or as a common person. Engineering that nature teaches us, that is durability teaches us. Durability means, it's a very small word for engineering, but it's a very important word. You can see whatever part of nature which we do not know or we can't have any control, it has been there for use, for millennials, for how many more years, centuries, millennials have gone. We do not know this earth, this solar system has been in existence and been successfully working 24/7, never stops. We take rest, we can stop, we can go on movement here and there. We can have luxurious residence. We do whatever we want for our entertainment, for our leisure, but nature does not require that. Sun has a role, sky has a role, every star has a role, and earth, of course, we have in air, and we see it has same system, it has same. There is no change. It's a casual one. We cannot say that today earth has stopped rotating. Can we say that? Can we say the earth has stopped orbiting sun? We cannot say that. Can we say there is a plan that sun won't? You can't see sun for 5 years to come. Can you say that? No. It has system. Automatism exists. What automatism shall we give? Nothing. There's already automatism existing. The whole solar system is automatic. Whole universe is automatic. Birth of a child is automatic. Death of a person is automatic. Who can control this? Can you control that? We cannot control that. Can we control birth? We cannot. Of course we can say, but when we can control birth to some other extent, not this way. If you want a child, you do not know when it shall come, how it happens, how it is constructed, what designs is, what are circuits, we do not know. This means nature has not told us, nature has not revealed to us facts, and we may not know them. I don't think we'll get some time to know, because we are not constructive world. We are destructive people. We want to break. Breaking is very easy. If we want to break something, it takes 1 day or 2 days. If you want to make that, it will take 1 year or 2 years. And that's the difference between making and breaking. And making and breaking is a part of quality. You make it or you break it. It's up to you. Or breaking comes only when it exists. And if you don't have capacity to provide quality, there is no issue that it can be broken because it doesn't exist. You can break only when you are qualified for that. This means you are not even qualified for breaking. How can you be qualified for making? And that's an important point. People don't understand these points really, making and breaking. Yeah, you make it, it will take time. And you see, you can experiment yourself. You break something, it doesn't have much work to do. It's very easy and damage cannot be repaired again, it cannot be reinstated. But if you make it, it will take your whole life. You can't do it completely. Making is very difficult, always very difficult, and it's also understandable. Those people who are oriented for making, they don't have times to waste. They don't talk a lot, they do a lot. Nature never talks to you, remember. Did you ever notice? You are a student, everybody is a student. We see nature every day. Does it talk to you? It never talks to you. Yes, it talks to you indirectly. It talks to you through thunderstorm. It talks to you through earthquake. It talks to you through natural calamities. It talks to you through viruses. It talks to you through many we can't understand. It gives us messages we don't understand. It gives us messages that be qualitative, be pollution free. Think of me, serve me, it's my material. Did you ever notice that? But we have been exploiting all materials. In construction also we have been using all materials. In our life we have been using all resources from earth. That's what my subject is about this one, but because when we talk some things, another point also comes in. We talk of concrete. Concrete is very much part of civil engineering. Without concrete, I think nothing can work, nothing can exist. And that's the point I put in. From where we get concrete? Concrete material, from where we get? I'm talking of quality, but what quality I'm talking of? I'm talking of quality of ingredients of concrete. Means whatever materials concrete produce, whatever materials concrete produce is strong material, solid material, that's concrete. It's got strength, it's got solidity, it's got life. But from where? Who is inside? Inside that are ingredients, we call it concrete ingredients. Inside is stone pieces, sand particles, water, cement, and likewise, whatever we have discussed. From where do these come? From where? These particles come from where? These particles come from nature. These particles come from earth hidden resources. Rocks we can see, these particles come from the movement of these particles from one place to another. Of course we know movements of particles through sand, through sand and through river. Particles move on through wind, you can say wind is an agency for that, water is an agency for that. These particles lie everywhere, and water itself is a material. So we can say, and then we ourselves we are also natural. We cannot say I can construct myself, I construct you. It's natural. So we have to think this way, that all are natural. Concrete, though we say we produced it, but without these ingredients, materials, we cannot produce that. We cannot produce concrete. We cannot produce cement mortar or other mortar. We cannot produce lime. We cannot produce rock. We cannot produce sand. We cannot produce water. So when we are supported by natural agencies and without these ingredients, we can't do anything. Then why don't we change our mindset? Why can't we change our mindset? These are like, fruits. These are like, natural supports. We say we go to temple and say that we get prasad. This is like prasad. Food is like prasad. God gives you food, we take food. There is no contribution from us. We have to grow it, and nature helps us because we have soil, we have water, we have air, we have sun, and all these agencies help in growing crops. So we say we cut crops, we gain crops, we reap crops, and because of what? Because of this. If there is no land, no soil, how shall we get crop? That's the point. Means nature stays with us everywhere, but how do we help it? We help it by killing each other. We help it by destroying this material. We fight ourselves. Countries fight together. We help nature by by producing nuclear power and killing each other rather than helping each other. This is humanity, means a very weak organization. If there is something very weak on earth in current time, is humanity. We call humanity, but there is no humanity. This is killingity. We kill each other, fight with each other, destroy each other, throw out one person from one place to other place. That is what's happening in this age. Human is no more human. Human has become, I think animal is better than human, that's what I can say. Because at least animal doesn't need something, doesn't need anything that's more than food. Animal doesn't need clothing, animal doesn't need immediate housing, animal can survive in sun, animal can survive in hot weather, cold weather. To some extent, we can't do that. That's the difference between animal. I think domain of animal is better than domain of human being, because human being requires everything at any cost. And animals have to walk, they don't travel by cars, they don't take flights, they walk, and only for sake of food they struggle. But where do we struggle? We struggle to destroy everything, and we have destroyed. We have polluted God-given air, we have polluted God-given water, we have polluted God-given minds, we have polluted everything. That's why I say quality doesn't mean only work quality, it means quality in life. Imagine today, had there been very good air, as it was in the beginning, what would have been there? Had there been old trees or woods, but we developed in construction engineering, we developed lands, we developed areas, and while developing, we spoiled them also. That's it means we developed not for positivity, we developed for breaking, we developed for destroying, and we've done it. We have done it wonderfully. I think we should be given, if there exists some prize, universe prize, we should give prize to this earth, that you people have destroyed this earth. And not now, it has been happening for long. So my dear friend, if I talk of quality and coordination, it doesn't mean I talk of engineering only, I talk of society, because engineering is a part of society. Society is not part of engineering. Engineering is just one part of society, medical is another part, administration is another part, one more, and you can see so many other parts exist in society, and we have therefore to link ourselves to everybody, and we say the term that is reliable engineers, and engineers are expected to be more intelligent than others because of use of mind, because of understanding, and it is engineers who are to some extent responsible for development, and they have to think for good of everyone. It's not only salary or your package, that's one part, but the responsibility is another part. Don't forget that everybody cannot be engineer. Don't forget that everybody cannot become doctor. There are few people, only few percentages only, though we get in our country 5 lakhs engineers per year, but how many of them are real engineers? That's the point of view. Those come only for purpose of packages or good life, or they come for serving society. And that is different points. I mean, we should get engineers who serve. We should have that capacity, we should have that requirement. Our life is different, and we should have that, we should get that much, Civil engineering is not easy, we understand. It's difficult to learn, but the application is more important. Whatever we learn in civil engineering or other engineering, how many percent of that we carry out in life, particularly civil engineering, because civil engineering is kind of raw engineering. Raw means field engineering, practically speaking, like a farmer inundates land and grows crop, kind of that kind of work is engineering. Engineering cannot be otherwise oriented that way. If you really want to get development, civil engineering is that only. You have to deal with civil engineering for that purpose. क्या हो गया? क्या हो रहा है? अच्छा, anyway, so my dear friends, that's where quality cannot be left. It's important. Quality cannot be left, cannot be left. That point is clear. You have to understand that point. You cannot live quality even if you want, because you are an engineer and nobody shall accept if you live quality. You cannot live quality otherwise. Engineering is root of that. You have to understand that point. And comes then coordination engineering. We have to think of reliable quality engineering, not just engineering. Reliable quality means quality that includes service, that includes safety, that includes durability, and that's what we have been learning. We have been reviewing specifications of engineering. And if we miss coordination, we miss good engineering. That might we have to realize. We should not miss coordination, but if we miss everything. That must be clearly understood. Sometimes it looks boring, of course. It's boring in fact. In fact, if I can, based on my experience, say, if somebody raises this question about coordination, I would simply say it's very boring and very interesting also. Can you think of that? Both poem, it's like a coin. One is head, one is tail. I would say it is boring, but also it is interesting. It depends on your choice. There are some people who start feeling bored too early. Oh, start thinking, oh, what a bore work it is. I know. I've seen many people who think that engineering is boring. Yes, it is boring. It is boring for those who do not know. Without engineering, they cannot survive. Of course, without engineering, you cannot survive. You think of if there's no electrical supply in your home, can you survive? There is no, there is no water supply in your home. Can you survive? There is no crop. Can you survive? Think of that. There is no food. Can you supply? Can you survive? Of course, you survive to some extent if there is no cloth for you. You can survive. There is no home for you. You can survive if there is no. You can't survive. There is no food for you. But home is second. Cloth is second. First is survival. Your stomach should be fed. That is important. But in water supply system, what is how it is supplied to your home, you can think of that. A home in which you are living, you can think of that how it is built. Same way you drive on road, how that road was constructed, how. And car or bus or train you are using, who produced this? You have to, everybody knows this, but who thinks in analytical terms? Moving forward, and this is where I say we have to think of quality requirements and coordination. And coordination is that branch where it says, okay, this is balanced life. We can say it is balance of life. Coordination means balance of life. We have to think of balance of life, equilibrium of life. In fact, in engineering terms, if this is balance in normal terms, this is balance. You have to keep balance. We say in ordinary language, but in fact, this is equilibrium. Means if we say, you can say there are three of life. You can sleep in wood also. You can sleep in open areas also. But when you have small house, you can sleep in, or you have apartment you can sleep in. Well, my point is this, that coordination doesn't mean engineering coordination. Coordination means general coordination. Coordination plays its role everywhere in life. Just like quality plays its role, cost plays its role, requirement plays its role, definitions plays respective roles. We have to keep that point intact in mind. And because I'm talking of coordination, and without coordination we cannot do anything, just like my mind coordinates with my body, every part coordinates with other part of body, every person coordinates other person. To while doing so they may not realize that they are coordinating with each other. When you talk to others, it's a kind of part of coordination. When you write to others for some question answer, it's also a kind of in extracting information or delivering information. So you can say it's a kind of big communication. It may be written or it may be spoken, or it may whatever way. Communication is communication. And communication constitutes coordination. And coordination constitutes quality. And quality constitutes work. And work constitutes project work, project delivery. And project delivery constitutes permanent work. Some may be called technically it is coordination or it is liaison. That's up to you to decide. But information is important. Signals are down again. 0, 0, 0, 0. I don't understand what's happening. There's no coordination. The service provider, Airtel. What to do? I don't think it will continue. 32 minutes only gone. 0, 0, 0 again. I don't know what's purpose, why it's happening. Let me put it again. Hope something has come back. No problem. Let us see how it works, how it behaves, how it constructs. Let me see. Coordination is coordination. We can't break it. We can't expect miracles from others. I have explained many times what is coordination, but I have also elements. You have to think yourself what is coordination. Coordination is something, a kind of leadership in our life. Coordination means it teaches us how to handle, how to find solution, how to analyze situations, how, if analyses are available, how to synthesize them. You see, we have both ways. If we analyze, we have to synthesize. If there's something available without understanding, to analyze, to understand, means both move. There's no physical analysis or physical synthesis, a mental analysis, a mental synthesis. Just like we say, oh, this is this material, we don't know what exists in that. So we analyze that to know, we test that to know what constituent does it have. That's what we say. Analysis and synthesis are in that way. You see, communication based coordination means we must have no resource. We must know source from where we got this information, and that information is for purpose of our works. For purpose of utilizing that information to work, and depends on what sort of information it is, how good it is, and how applicable it is. The points are very important. That's why I say missing coordination means missing good engineering. Communications and coordination, you can work in engineering, and based on that we see projects are delivered. Not now, before also. Now it's computer world. You can say we have every media either we can immediately find information. Maybe it's right or it's not relevant or irrelevant, but we can at least find information from internet. Millions and millions of files are available on the internet. My files, your files, whole world files. And whatever we write, we search for and get something, and we can find whether it's useful or it's not useful. And that's what's a kind of free coordination is. Free information available. Even then you have to find out, to search. It doesn't take much time if you compare it to 30-40 years back. when I was in 1985-6, I was here on this project. You can see on this screen. I coordinated for this construction for 1.5 years for everything. Of course, there were errors and errors and errors sometimes, but if there are 2% or 1% error, you cannot see this gone waste. Likewise, there was a computer in those days, and there was nothing, no typewriters. You had to type yourself, write yourself. Physical world, communication was time consuming, and you had to move one place. There was nothing as such, no backing, but coordination existed in that mode, in those modes. Now coordination exists in different modes. Communication is very fast, it's too rapid, even you cannot sometimes understand how fast it is. But excess of everything is bad. Too fast also means not good, because it should be correct, that's required, not fast. Speed is not required, correction is required. Value of that coordinated material is important. If you just keep on coordinating very fast and we don't for me if it can't be used, and that's most important. That is requires selection of information. I have to realize that what I get. Again, signals are down just in a couple of minutes. These are down again. That's really a problem of use of internet and live videos. It doesn't work. 0000. Maybe while I'm talking, it's not being recorded. I cannot say how many. Oh, I don't know. This I think it's going to die maybe. Well, my dear friends, I tried to explain to you this time. These projects I'm showing to you, these are all old projects. This was also a building in Iraq. It was constructed in 1980, 81, 82, 83, 84, etc. And also there's another one. So many are here in those days. All this is computer oriented work. It's not that one. And it is, there are so many. This is also, computer world. So I think that was only I just wanted to share with you those areas where, yeah, this is also without computer time. This firing range, this exists in Doha, Qatar, in 330 meters line. This was constructed in 1986, 87, 88. There was no think thinking of desktops even, and you can see this is computer drawing. This is also computer world project, so I can't claim on this. I just try to share with you why actually I want to say that's important point. And I don't think yes, this is also computer time. And I am not saying computer did this. Computer was involved in that. I think so. I have not to that level. Yeah, in this time, 1995, 96, I was involved in this LNG project tanks, and also I was in charge of villa building, same city, and this was called Raslaffan city, industrial city, oil city, and we used to do record surveys of these tanks manually, because that's done manually only. The computer won't do it, and that's why lot survey were done without computers. Computers were there, but not to my level. Only those who had knowledge of DOS and other could do it, but I did not know anything about computer at that time. I'm talking of days of computer days. Areas, and so that I can't make any claim that we don't use computer in those days. We used, and now without computer, I think we can't move, and that's really a big problem. In fact, we have become slaves to computer, and that's not good thing. And we'll go back to concrete file. Why to waste time? Now we're back to concrete file. That is durability of concrete we discussed yesterday. Again, I refresh materials used in concrete. Materials used in concrete shall not be done events that have adverse effects on required durability of concrete. It should have good effect on concrete. That's what durability means, and that the good effect should continue for long travel, 50 years. Old structures still survive all over the world. In our country itself, there are many structures have been many centuries old and still surviving, and this means concrete can survive for more than that if it's properly cared for. That's what I mean to say. And durability is undefined. In fact, we give safety coefficient around and define this durability of this, but real life would be more than that if proper. Let us do something. It's too much, I think. Now it's done. So let us say 165. Otherwise, in that case, so we go further and talk this in this way. Materials used in concrete shall not be ones that have adverse effects on required durability of concrete, and water cement ratio of concrete should be 65% or less, and concrete used should be air entraining concrete. Durability of concrete is determined by environmental action, materials used therefore shall not have adverse effects on durability of concrete, and mixed proportions required to be selected properly. I'm saying required to be selected properly. Shall not have adverse effects on durability of concrete. Shall not have adverse effects on durability of concrete. And mixed proportions required to be selected properly, and you can say material that meet requirements of this chapter, else material should be used in order to prevent alkali silica reaction, from reaching a harmful level during service period. You can say one of these three methods shall be used, and which are: number one, reducing total alkali content. Reducing total alkali content of concrete, and otherwise using type B mixed cement that is effective in suppressing alkali silica reaction. And also other one is using aggregate that is classified as category A, we can say harmless, in an alkali silica reactivity test. Further details of control methods are described elsewhere. Its intrusion of alkalis from an extend source from external source is inevitable. If intrusion of alkalis from an external source is inevitable, as as in a marine environment, as in a marine environment or in a region where de-icing agents are used, and is use of alkali, if use of alkali reducing measures relying solely on materials used in is deemed to be inadequate, it's necessary to consider use of additional measures such as surface covering, water cement ratio. Concrete becomes less durable. We have to take this point. Increase in water cement ratio means concrete becomes less durable. Signals my enemies you what to do, I don't know. My enemies are signals here. 7 fps, 00 video and 00 audio. What to do? I can't speak this way. Anyway, sometimes it comes and sometimes it's going a couple of seconds, this come and this go. So what I say, coming some problem in reading this. I think now it's okay. I'll keep it different way. So it's okay now. Yeah. I says that as a general rule, this water cement ratio to be actually used, to be actually used, varies depending on expected degradation factors, and specific details of determination method are described. Designs general requirements of specification. It should be kept in mind, however, that water cement ratio is too low, content cement content becomes relatively large and very large, and heat of hydration and autogenous shrinkage increase, so that durable concrete adverse is going down, no signals. I think it will fall. To do. Nothing is working, it's not working yet. No, it's not working. Oh, 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 oh. My God, what to do? Well, let us go move further. Something has come. Let us see how long it works. So I was somewhere. It should be kept in mind, however, that if water cement ratio is too low, too low, it says cement content becomes relatively large. Cement content becomes relatively large, and heat of hydration and autogenous shrinkage increases, so that durability of concrete adversely affected depending on type of structure. Water cement ratio of concrete subjected to chemical attack shall meet requirements. Now let's say for the verification, we can say verification. What's happening? I don't know. It's hung up. So let's say it says the water symmetry is the most important part. So it's okay. Now let's go verification as to whether a concrete structure meets the freeze thaw resistance. That's question here. Verification as to whether a concrete structure meets the freeze thaw resistance requirements is made by use of relative dynamics, dynamic modulus of elasticity. In freeze thaw testing, reference values shown in design drawings and specifications are water cement ratios that meet required relative dynamic modulus of elasticity in design general requirements of this specification. Now we have cycles. Entrained air bubbles reduce water it says entrained air bubbles reduce water pressure, increase due to freezing of internal water. Use of air entrained concrete therefore is very effective in improving freeze thaw resistance. What says entrained air bubbles reduce water pressure and increases due to freezing of internal water. Use of air entrained concrete therefore is very effective in improving freeze thaw resistance. Furthermore, use of air entrained concrete substantially reduces the amount of water required to achieve required workability so as to facilitate complete filling with concrete and improve durability required. Air and trained, I'm saying, when trained in air and trained in concrete we used not in cases where severe weather action is involved, but also in cases where severe weather action is not involved. And steel protection performance. Concrete shall be capable of protecting steel placed in concrete. That should be concrete should be that much capable to protect the steel which is in, so that steel can perform its intended purpose during service period of concrete or that member. As a general rule, total amount of chloride ions contained in concrete when it is mixed should not exceed Concrete has functions of protecting steel in concrete from external corrosion factors, heat from fires and other heat sources. Many concrete structures have reinforcing bars and other reinforcing steel in concrete. If reinforcing steel corrodes, therefore durability of those concrete structures decreases considerably. Reason why protective function of concrete is lost is protective passive film on steel surface is destroyed. Destruction of protective passive film is caused mainly by a decrease in alkalinity due to carbonation and presence of chloride. Concrete rate of carbonation of concrete shall not reach critical period reach critical period, and chloride ion content of this concrete at steel location. You can say chloride content of concrete at steel location shall not exceed level at which protective passive film on steel is destroyed. Thus, from viewpoint of protection of steel, it is necessary to select materials and mix proportions so that concrete is provided with appropriate mass transfer resistance. It is necessary to select materials and mix proportion so that concrete is provided with appropriate mass transfer resistance according to concrete cover determined at design stage. Water cement ratio is determined at design stage along with concrete cover, and whether required durability is achieved is verified. It is general rule, therefore, to use a water water reducers, air entering water reducers. One is water reducer and one is air entering water reducer. Super plasticizers, etc. improves workability and reduces segregation. So I said use of air entraining agents, water reducers, air entraining water reducers, super plasticizers, etc. improves workability and reduces segregation such as bleeding so that homogeneous concrete with relatively few defects can be obtained. Use of those chemical admixtures therefore is effective in improving steel protection function of concrete. Also, if blast furnace cement or fly ash cement is used, or if an appropriate amount of high quality pozzolana is used in an admixture, fine textured concrete is obtained. If blast furnace cement is used, ability to fix chloride ions. Let me see percent of my battery. Still it is 56%, so it is okay. Let me continue. If blast furnace cement is ability of used ability of to fix chloride ions in concrete is enhanced. Thus, use of these mixtures can be expected to reduce intrusion of elements that cause steel corrosion into concrete. It should be kept in view, however, that steel protection performance in cases where these types of cement or pozzolana is used can be achieved only if a sufficient initial wet curing period degrade steel protection performance, that is cracks in cover crack with is not critical crack for steel corrosion is not is not concrete can considerably degrade steel protection performance, and we have to be careful about this. Or say it's therefore necessary. You can say it's therefore because there's a single I'm repeating. Yeah, it's therefore necessary to achieve durability by exercising controls so that critical crack width critical crack width for steel corrosion is not exceeded. If concrete surface should be taken. That's an important point. Means if, as said, provisions in concrete is not going to work, we have to use epoxy coated steel. It's a common point and good replacement point for purpose of explanation. Why do we use epoxy coated steel? And that's purpose of that it can protect its surface, that is steel surface, from impacts of carbonation and rapid chloride penetration, and that's advisable to refer to recommendations. All right, we go further now. That's concrete structures using this epoxy polyethylene behind now. Go to if chlorides now. Limit corrosion of steel in concrete is accelerated so that The deterioration of structure can result. Such chlorides may enter concrete from external environment, and as such as marine environment, or be supplied to concrete from materials such as cement, aggregate, chemical admixtures, and mixing. So chloride penetration has to be protected. It can enter from environment. Mixing. The remixing is the control, means one chlorides or percent of chlorides entering in, or coming columns in, total chloride ion content of concrete supplied from materials used to concrete calculated on basis of mixed proportions. With mixing concrete, therefore, it's necessary to know in advance chloride ion content of each material. If top water is used, now we have to calculate whatever contents of ingredients chlorides in, those are all to be combined for purpose of knowing total quantity of, and we have to make sure that it should not exceed 0.04 kilogram per meter cube water. If tap water is used as mixing water and chloride ion content of that water is not known, and the quantity of chloride ion supplied from mixing water to concrete may be assumed to be 0.04 kilogram per meter cube. Amount of increase in chloride ion contents of concrete is not large enough to cause a serious problem unless cement content is extremely high. Limit value stipulated in this section. Namely chloride ion content of 300 gram per meter cube, is not intended to guarantee that steel corrosion will not occur. Instead, value has been determined on basis of research and study results, as if you can say feasible value that can keep deterioration of structure due to steel corrosion at or below an acceptable degree. Therefore, in case of, for example, pre-stress concrete subject to stress corrosion, Just a minute, please. Let me see one part of this. It's called stress corrosion. There was a term, stress corrosion is another form of corrosion that's important to many fields, including civil and structures. Stress corrosion occurs when a material exists in a relatively inert environment but corrodes due to an applied stress. Stress may be externally applied or residual. Stress corrosion is a growth of crack. Stress corrosion cracking is growth of crack formation in a corrosive environment. It can lead to unexpected and sudden failure of normally ductile metal alloys subject to tensile stress, especially elevated temperature. Stress corrosion, what it says, let us see furthermore. Stress corrosion. What is stress corrosion? Let us see this. Definition from Wikipedia. Stress corrosion. Let's make it what it says. Stress corrosion cracking is growth of crack in formation in a corrosive environment. It can lead to unexpected and sudden failure of normally. Just a minute, please. Let me see what it says. It's easy to understand, but explanation is also an issue sometimes. I don't know if it's open. It's not. Yeah, it's responding, I think. It says stress. Let me read. It's only one paragraph here. I'll read for you so that you can get information about this. And this is stress corrosion cracking. What does it mean? Stress corrosion cracking is growth of crack formation in a corrosive environment. Crack formation in a corrosive environment. It can lead to unexpected and sudden failure of normally ductile metal alloys subjected to tensile stresses, especially at elevated temperatures. Stress corrosion cracking is highly chemically specific in that certain alloys are likely to undergo SCC only when exposed to a smaller number of chemical environments. Chemical environment that causes stress corrosion cracking for a given alloy is often one which is only mildly corrosive to metal. Hence, metal parts with severe SCC can appear bright and shiny while being filled with microscopic cracks. This factor makes it common for stress corrosion cracking to go undetected prior to failure. Stress corrosion cracking often progresses rapidly and is more common among alloys than pure metals. Specific environment is of crucial importance, and only very small concentrations of certain high active chemicals are needed to produce catastrophic cracking, often leading to devastating and unexpected failure. And this stress can be a result of crevice load due to stress concentration, or can be caused by type of assembly of residual stresses from fabrication. Cold working call it. Residual stresses can be relieved by annealing or other surface. So metals, austenitic stainless steel, certain austenitic stainless steels and aluminum alloys crack in presence of chlorides. This is austenitic stainless steel and aluminum alloys crack in presence of chlorides. This limits usefulness of austenitic stainless steel for containing water with higher than few parts per million content of chlorides at temperatures about 50 degrees Celsius. Mild steel cracks in presence of alkali, boiler cracking and caustic stress, corrosion cracking in nitrates, copper alloys crack in ammoniacal solution, season cracking, high tensile stress have been known to crack in unexpectedly brittle manner in a whole variety of aqueous environments, especially when chlorides are present. When possible, exception of later, it is a special example of hydrogen cracking. All other displays phenomenon of subcritical crack growth. Polymers, a small process, environmental stress cracking occurs in polymers when products are exposed to specific solvents. Likewise, there are so many others. We'll discuss it later on stress cracking, but definition itself says that stress corrosion cracking is growth of crack formation in corrosive environment, which can lead to unexpected and sudden failure of normally ductile metal alloys. Normally ductile metal alloys subject to tensile stresses at elevated temperatures. SCC is highly chemically specific in that certain alloys are likely to undergo SCC only when exposed to a small number of chemical environments. So this point I put it now. It's just something valuable information. That's why I shifted to and announced it by reading. It's not my announcement, just by reading some Wikipedia file. I did not show you because very small information I had to tell. Takes time. So what's the limited value? Limit value is stipulated in this section, namely chloride ion content is 0.3 kilogram per meter cube. It's not intended to guarantee anything, you can say. That's the important point, that isn't guaranteed nothing will happen. Instead, value has been determined on the basis of research, nothing else. Therefore, in case of for example, pre-stressed concrete subject to stress corrosion or reinforced concrete that is used in an environment with chloride adaptive to chloride ion intrusion or electrolytic corrosion, and that is required to be highly durable. It's a chloride intrusion or electrolytic corrosion, and that is required to be highly durable. The quantity of chlorides in concrete should be made as small as possible in comparison with specified value. In case of reinforced concrete, we can say, in case of reinforced concrete, if you say this, in case of reinforced concrete, of plain concrete with non-structural reinforcement, to be used under normal conditions, if materials with a low chloride content are very difficult to obtain, allowable upper limit of total chloride ion content of concrete may be raised to 0.6 kilogram per meter cube. In this case, however, it's necessary to carefully carry out construction, taking particular care, among other item requirements, to make water cement content or water content as small as possible and place concrete properly. Provision of this section do not apply to structure built with plain concrete without non-structural reinforcement. It's been pointed out, however, that even in case of concrete used for structural of this type, structures of this type, there may be adverse effects such as poor strength development over a long period of time and increased proneness to efflorescence deposition as chloride ion content increases. Total quantity of chloride ions therefore should be minimized. Water tightness. Now we come to next one. Concrete shall have required water tightness so that functions of structure are not lost because of water permeation. Water tightness includes water tightness of concrete. Percentage of better, let me check, it's maybe down, otherwise 35% put it on. We can't wait, try to put it on. Water tightness includes water tightness of concrete and water tightness of structure or member. We can say water tightness of concrete is evaluated in terms of permeability coefficient of concrete, coefficient of permeability, and later in terms of permeation rate. Permeability coefficient is basically dependent on solidity of concrete, how solid it is, and concrete with high solidity, that is concrete with small permeability coefficient, is desirable from viewpoint of durability. Permeability FA coefficient is governed by degree of compactness of hardened porous concrete, how dense it is. More dense, more means compact, how compact it is. Hardened porous cement. Permeability F coefficient is governed by degree of compact or being compacted. Void structure characteristics such as void continuity and nature of relatively coarse textured transition zones formed around aggregate particles. Void structure of hardened cement is usually dependent on water cement ratio and type of cement material, cementitious material. Transition zone formation and continuity vary with water cement ratio and degree of segregation. That's called breeding. And width of transition zone increases, distance between aggregate particles decreases. Continuity of transition zone tends to increase and permeability coefficient of concrete tends to increase. It is generally known that water cement ratio increases, permeability coefficient of concrete increases exponentially. In order to achieve required permeability coefficient, it's effective to reduce water cement ratio and water content to extent that workability suitable for construction tasks to be performed can be achieved by using admixtures, etc. appropriately so that homogeneous and compact concrete can be obtained. Past experience confirms that water tightness requirement of ordinary concrete can be achieved if water cement ratio is 55% or less. Whether functionality of a structure is not hampered by water permeation is verified. We put off care of this now. Whether functionality of a structure is not hampered by water permeation is verified. General requirement of specification verification of water tightness, because permeation rates are indicated in design drawings, and we can say because permeation rates are indicated in design drawings and specifications as characteristics values, it is necessary to carry out construction so that those values are met. Water tightness of concrete structure is closely related to not only water tightness of sound regions of concrete but also water tightness of discontinuous surfaces such as crack and joint. So what is water size? Water tightness of concrete structure is closely related to not only water tightness of sound regions of concrete but also water tightness of discontinuous surfaces such as crack and joint regions. Crack and joint regions in general, rate of permeation through cracks and vertical construction joints tend to be much higher. It says if It says water tightness, but also what discontinuous surfaces such as crack and joints. In general, rate of permeation through cracks and vertical construction joints tends to be much higher than rate of permeation in sound regions of concrete. If water tightness is required of a structure, if water tightness is required of a structure, therefore occurrence of cracking should be prevented. Use of reinforcing bars for crack control and expensive admixture is effective in controlling occurrence of cracking and crack width. Occurrence of cracking and crack width. Also, it is basic rule to treat construction joints properly and use water stops at vertical construction joint. Construction related measures that can be taken include laying waterproof membrane in regions where water tightness is required, using crack inducing joints and taking appropriate waterproofing measures after cracking. When taking these measures, it is important to properly evaluate those measures, including maintenance plan, and decide on details accordingly, because effectiveness of such measures differs depending on factors as materials and methods used. Cracking resistance. Concrete used shall be one that is free as much as possible from settlement cracking, plastic shrinkage cracking, thermal cracking, autogenous cracking, drying shrinkage cracking. Many cracks that have occurred at surface of concrete structure may mar appearance of structure or cause performance of concrete such as durability, and cause performance of structures such as durability, steel protection performance, water tightness and air tightness to be degraded severely. Cracks resulting from excessive shrinkage may also have adverse effects on stiffness and deflection of structural members. Influence of cracks occurring at construction stage on performance of structure during its service period has not yet been fully understood. Verification, however, of various performance attributes described in design, that is, general requirements of this specification, assumes that initial cracking that is so harmful as to defect required performance of structure doesn't occur at construction stage. It is necessary, therefore, to minimize occurrence of cracking and control cracks so that they do not affect performance. Let's keep crack width within tolerance. Intent of construction standards of the specification not to completely prevent cracking. Instead, it is to prevent harmful cracks that degrade include those attribute to materials of mixed proportions, those attributes to construction work, and those attributes to external forces, causes of concrete. Causes of cracking attribute to external forces can be taken into consideration at design stage, and therefore there are even types of cracking, such as flexural cracking that are allowed to some degree. Initial cracking verified in designs is cracking to hydration of cement. Initial cracking without hydration of cement and cracking due to shrinkage. Intent is to verify Intent is to verify that these types of initial cracks do not affect required performance of concrete structure. Since design drawings and specifications indicate design values for materials based on verification and reference values related to materials used and mix proportions, construction can be carried out according to these values, as in cases where durability is to be achieved. Occurrence of these types of cracks, however, is attributable to not only nature of concrete determined by such factors as materials and mix proportions, but also various other factors such as environmental conditions, dimensions and shape of structure, and construction methods. There may even be cases where other factors that cannot be expressed, that cannot be expected at this design stage are involved. It's therefore necessary to select concrete materials, mix proportions, and construction methods after careful consideration of those factors and their effects. In order to reduce rise in concrete temperature, it's important to make cementitious metal content, as small as possible. Taking measures such as keeping material temperature low is a good construction practice. From previous studies, it has shown that autogenous shrinkage cracks, while autogenous shrinkage increases, while water cement ratio is low, and that amount of shrinkage varies widely depending on type of cement and admixture used. In case of high strength concrete, it is smaller than normal water cement ratio. It's important to select appropriate materials and mix proportions. In order to control drying shrinkage, it's important to make water content as small as possible. It's also important not to use high absorption aggregate or aggregate with a small Young's modulus. Shrinkage strain should be small, but it is important to ascertain in advance by referring to past construction data or reliable literature that concrete material and mixed proportions to be used are free from cracking due to shrinkage. Design general requirements of this specification requires that maximum allowable shrinkage strain in concrete should be 1200 micron. General requirements of specification that states that maximum allowable shrinkage strain in concrete should be 1200 micron. If past construction data or other relevant information is not available concerning shrinkage of concretes to be used, this value is obtained by assuming that measured value of length change obtained by water curing, that is 100 into 100 into 400 mm, specimen for 7 days at 20 plus minus 2 degrees Celsius, and measuring length change, that is 20 plus minus 2 degrees Celsius, and relative humidity 60 plus minus 5%. Judging from past construction data, it may be thought that shrinkage strain in ordinary ready-mix concrete is not greater than maximum value mentioned. If however a very important structure is involved or shrinkage cracking has a serious impact on performance of concrete, or if a smaller shrinkage strain is specified at design stage and value mentioned above needs to be verified through testing. Common type of cracks that occur at construction stage. Common types of cracks that occur at construction stage besides shrinkage induced cracks intended above include settlement cracks and plastic shrinkage cracks. An effective way to prevent settlement cracks is to use admixtures with water reducing agent and mix proportions with a low water content. Cracking can also be prevented by careful construction, and settlement cracking can be prevented by reducing bleeding. So cracking can be prevented by careful construction, and settlement cracking can be prevented by reducing bleeding and carrying out damping or vibration at appropriate times. Plastic shrinkage cracking can usually be prevented if rapid drying from surface following placement of concrete is prevented. It is if rapid drying from surface following placement of concrete is prevented, plastic shrinkage cracking may occur when rate of evaporation of water from surface is higher than rate of rise of bleeding water. In case of high strength concrete that is relatively free from bleeding, it is important to prevent dissipation of moisture. Constituent materials. Constituent materials used for concrete of which quality has been confirmed. How it is? Choice of appropriate constituent material is very important, ensuring that concrete meets required performance criteria. Suitability of constituent materials can be confirmed using quality control tests or service records. Also, constituent materials conforming to standards of quality, such as those laid down, may be confirmed as good quality materials. Materials to be used for concrete shall be determined so as to satisfy required performance, taking into consideration of limitations of production plant use. Cement shall comply with requirements of these. When cement other than types of cement mentioned is used, it shall be ascertained that performance requirement of concrete are met. It is necessary to select most appropriate cement for construction by considering types, sizes and location of structures, weather conditions, time and duration of construction, construction procedures, etc. to produce concrete of required performance steadily and high strength, higherly strength, very higherly strength versus normal, higherly strength, very higherly strength, moderate heat, low heat, and sulfate resistant. Moderate heat, low heat, sulfate resistant, Portland cement, and Portland cement blended, Portland cement blended cement conforming, and Portland blast furnace slag cement, Portland pozzolana cement, and Portland fly ash cement, and cement conforming. Eco cement. In many projects, normal Portland cement is used. Other widely used types of cement includes high early strength and moderate heat cement. In Portland cement category, blast furnace slag cement and fly ash cement. In blended cement category, in recent years, use of type B blast furnace slag cement has increased. Today, cement is being expected to continue to contribute to realization of a zero waste society by making it possible to reuse byproducts from other industries. So we were saying what we now, let us say signals again a problem, and that's point. Eco cement was here at eco cement. In many projects, normal Portland cement is used. Other widely used type of cement, include high early strength and moderate cement, heat cement, Portland cement category, and blast furnace slag cement and fly ash cement in blended cement category. In synthetic type B blast furnace slag cement has increased today. Cement is being expected to continue to contribute to realization of zero waste society by making it possibly to reuse byproducts from other industries. In 2003, in order to meet growing demand for industrial byproducts, that can be used as materials for normal Portland cement. Allowable upper limit to chloride ions content was raised from 0.02% to 0.0035% or 0.05%. In general, use of higherly strength Portland cement in a low temperature environment decreases degree of delay in strength. You can say, in general, use of higherly strength Portland cement in a low temperature environment decreases degree of delay in strength development. In general, use of higherly strength Portland cement in a low temperature environment decreases degree of delay in strength development at early material stages. In case of low temperature curing thereby making concrete less susceptible to damage by free thaw cycles. Use of high strength Portland cement is a high temperature environment is in contrast contributes to a rise in concrete temperature because of large amount of heat generated. General use of high strength cement, higher strength water cements, low temperature environment decreases degree of delay instant development at early materials ages in case of low temperature curing, thereby making concrete less susceptible to damage by freeze thaw cycle. Use of high early strength Portland cement in a high temperature of an temperature environment in contrast contributes to rise in concrete temperature because of a large amount of heat generated. By hydration making spreading of concrete more difficult because of stiffness of concrete resulting from high temperature and making concrete more prone to cracking. In a high temperature environment, therefore it is desirable that low heat, moderate heat of normal Portland cement or type B blended cement be used to reduce amount of concrete temperature rise and subsequent cracking due to temperature fall. Type 13 blast furnace slag cement is effective in reducing alkali silica reaction and chloride infiltration. Type B cement performs Type B blast furnace slag cement in recent years, however, tends to be formulated so that depending on slag cement, in this slag cement powder content, there is initial strength becomes high consequential. Consequently, there are cases of the cases where adiabatic temperature rise rate of concrete is higher than that of normal Portland cement. Constrained conditions percent, and there have been reports of increase in cracks due to thermal stress depending on member sizes. Constrained conditions, environmental conditions, etc. Since type B class furnace like cement includes all heat types, it's important when using it to check on its thermal and other properties and guarantee strength at a relatively old material age. Thanks to recent advancement in production technology, today it is possible to achieve required strength of cement even if water cement ratio is high. Cement today therefore is capable of meeting high early strength oriented performance requirements, aiming to achieve required strength at material age of 28 days. Some point out, however, that as a result, durability suffers. In coming years, there will be, and this will be another need for cement that develops appropriate strength at water content, water cement ratio, at water cement ratios determined by durability, that is cement that has a different strength for concrete with different strengths. In this case, our curing that takes early age strength development into consideration is important. Ecosystem, eco cement, you can say eco cement, which was newly standardized in 2002, can be largely classified into two types: normal eco cement and rapid hardening eco cement. Eco cement, which contains chloride ions in quantity equal to 0.01% or less of mass of cement, has properties similar to those of normal Portland cement. Ecosystem has made application to ordinary reinforced concretes possible. If quantity of Na2O or K2O contained in cement is large, particular type of minerals in aggregate may cause alkali silica reaction. If quantity of Na2O and K2O is large, contained cement is large, particular types of minerals in aggregate may cause alkali silica reaction under certain conditions, thereby causing deterioration of concrete. Methods for suppression: mesosuppression. Alkali silica reaction describes three methods for preventing reducing such alkali silica reaction to those who choose from. One is reduce total alkali content, total quantity of alkalis supplied by these materials, to reduce that. Reducing total alkali content of concrete to Na2O equivalent of 3 kg per meter cube or less. And other one is reduce blended cement content, a reaction surpassing effects. A reaction surpassing effects such as type B or type C blast furnace slag cement. Says what is that? Reducing total alkali content of concrete to Na2O equivalent of 3 kg per meter cube. reducing total alkali content of concrete to Na2O equivalent of and using aggregate that has been judged to be harmless, aggregate that has to be judged harmless with respect to alkali silica reaction. Reaction control methods are described in great details in explanation. Cement used mainly for civil engineering projects includes not only types of specified but also cement with special performance characters. Use of ultra rapid hardening cement. Ultra rapid hardening cement makes it possible to achieve high strength. Use of ultra rapid high hardening cement makes it possible to achieve strength in a short period of time and begin to use structure only several hours, even in winter. Since consolidation hardening properties of cement of this type varies considerably depending on quantity of hardening time modified use. Since consolidation hardening properties of cement of this type may vary considerably depending on quantity of hardening time modifiers used, it's necessary to obtain accurate information on consolidation properties at a temperature at which cement is used. Other special types of cement include ultra-fine cement, alumina cement, oil well cement, geothermal well cement, white Portland cement, and colored cement. When deciding on using these special types of cement, it's good practice to carefully study past construction records and conduct thorough tests in advance. Use of combination of two or more types of cements may result in unexpected results, such as quick setting of mixture of alumina cement and Portland cement. When mixtures of different types of cement are used, it's necessary to ascertain that such mixtures So it says a quick setting of mixture of alumina cement and Portland cement. When mixture of different types of cements are used, it's necessary to ascertain that such mixtures would not have adverse effects on performance of concrete. Now water. Mixing water should be tap water complying with provisions of appendices. Recovered water meet requirements described. Seawater should not be used as mixing water in general.